Well, hello, and welcome to another exciting episode of Fun with Physics. This is your host, Mr. Easley, and I hope you will enjoy. So, we're here working on the physics classroom, and we are looking specifically today for this video in the calculator pad, and we are looking in problem sets for kinematics, 1D kinematics. This video is specifically looking at problem set 17. These are a little bit trickier, so I'm preparing a couple videos for them. And when we look at this first question, it talks about a biker, and it's actually doing three things. And this is where some folks sometimes get a little messed up. There's three different things going on here. It's accelerating up to this point. It's staying at a constant velocity to this point, and then it's undergoing negative acceleration to this point. So the question is, it says a biker speeds up to 30 meters per second, and everybody's numbers are different, but speeds up to a certain velocity from rest over the course of a certain amount of time. The biker maintains this speed for a certain amount of time before coasting to a stop in a certain amount of time. What was the biker's average speed for this trip? Well, if we go back to our equations, what we would want to be looking at here is velocity average is equal to change in position divided by change in time, which is displacement over change in time. So in order to find that his average speed, we need to find his average displacement, or hers, and the time that it took. Now, we're trying to calculate the velocity average. It's pretty simple to get to the time, because the time is actually the sum of three things that is already told you. So we know that there's three different times here. There's time 1, time 2, and time 3. And all we would have to do is add those up to get total time. So we'd have 6.01 seconds plus 5.52 seconds plus 8.1 seconds. That would give you the total time, which you would need here. Calculating this, that would give you time. What you don't know is displacement, and that's where we get a little bit tricky, in that when we're looking at here, there is going to be a separate distance that's associated with this first time. Call that D1. A separate distance that's associated with the second time. Call that D2. And the third distance that would be associated with this third time, we could call that D3. And to really solve this, you're going to have to look at each of the three phases. If we're looking over there on the screen there, each of the three phases of what's happening with this biker as independent things, and then we'll add them together. All right, so in order to solve for this distance 1, you essentially go back to what we've already done, where you have a set of variables. You know the distance. I'm calling it D1, but it's basically distance. You know the initial velocity is 0, final velocity is 30, and the time is 6.01. So what we're going to do here is then you're going to look at your four main equations, and you'll try to identify one that would make sense given what you know and what you need. And of course, I would hope you would eventually determine that in fact it is that one, because everything's there. So you could use this equation to solve for this distance which would then allow you to use this equation using that distance you just solved and that time in order to get the, sorry, that's not correct. You actually have to add these three up when we feed that in. I'm sorry. That's confusing. You have to add these three up for when we feed that in. I said that wrong. Next up, we'll be looking at, we're going to be looking at the D2 here. How are you going to solve that? What's going to be the same thing? So in this scenario, for distance 2, we go over, and if you look at the original question over here, way over there, I don't know if I can highlight it here. It says you're doing this. Yeah, I can. 30 meters per second. That's from this area right here. You're doing 30 meters per second for 5.52 seconds. So that's where we get the velocity is 30. We have a time of 5.52. Could we find D? Could we solve for D? And yeah, we can. We could go back to, we probably could use one of these equations, and it's not a bad idea maybe just to look at that. We also certainly could use this equation if we wanted to, just to solve for, in this case, the D2, that part of the displacement. But we also could just as easily use this equation. And if we look here, although there's not one that just has distance and time and velocity in it, we actually could use this equation because there is no acceleration. Acceleration would be 0, so therefore all of that would cancel out. And so you could solve for D2, you could solve for D2 using this equation, because this becomes 0, and then your velocity original is basically your velocity you have right here. It's not changing, and you have your time, and so you could just use that in order to solve for your second D2. Now, continuing along, if we want to look at our third D3, we need to think about what do we have and how would we solve that. And in this scenario, it's essentially the inverse, the exact opposite. You literally would use all of the same information and the same equation from the first one, because as you do this, although these aren't the exact numbers, you would find that you have an unknown distance, but you have an initial velocity. And in this case, your initial velocity, since it's starting from 30, would be 30. And here your velocity final, since you're slowing down to a stop, would be 0. So those would change, but it's basically the same scenario. And then your time is different as well. In this case, your time is 8.1. But you would use the same equation and the same process to solve for D3. And once you solve for those three distances, then it's going to be as simple as you're going to add those together, those three distances together, and then those three together would be your total displacement. That would go into this equation here for displacement, divide it by your total time that you added up, and that would give you your average velocity or average speed for the trip. I will say, I don't know why that's not clearing. I will say that you also can always click this link right here, which is a really helpful, another person talks through a solution to it in just voice form. I think they go a lot quicker and probably a lot more efficiently than I do. But thank you. Make sure and like and subscribe, and I hope you enjoyed this video.